Assalamualaikum and good day. So in this tutorial, I will be showing about the relative motion analysis, and we are going to focus on acceleration. So in the previous lesson, we have learned about how to calculate the linear velocity of a point and also the angular velocity of a rod. So when you want to calculate velocity of a rotation, you will use this equation. VA equals to omega OA cross product RA slash O. And now we are talking about acceleration. So if we want to calculate the acceleration of point A, then the equation is AA equals to alpha OA, which is the acceleration of rod OA. This alpha here is normally given. Cross product RA slash O minus omega OA square. This is the same omega as what we have here, which is given these two values. And please notice that this is in scalar quantity. So which means that there is no ijk component for this particular variable, and multiply with RA slash O, which is the position vector, and again this is in vector form. So only one parameter here is in scalar quantity. And when we talk about general plane motion, we already discussed that VB is equal to VA, because when we want to calculate the velocity of B, we have to refer to point A. Okay, in the previous for rotation, we want to calculate point A, therefore we refer to point O, and in this case point O is fixed point, not moving, and therefore we don't include point O in the equation. So when we want to calculate the acceleration of point B, then AB is equal to AA plus alpha AB cross product RB slash A minus omega AB square in scalar also times RB slash A. So basically, you will notice that these two equation is almost similar, except for this part. Okay, there is reference to point A, which is also similar to the velocity equation. So this is two new equations that we will be using in this particular tutorial. So this equation number one to calculate the acceleration of a rotating rigid body, and equation number two is to calculate the acceleration of a point on a general plane motion rigid body. So let's go to tutorial question number 5, which involve both angular velocity and also angular acceleration. So you can notice here that it is given the disk is rotating in clockwise direction with omega equals to 8 rad per second, and there is angular acceleration alpha equals to 16 rad per second square. So this question has to be modified a little bit to include also calculate the acceleration of in this case point A, and angular acceleration of rod AB, Okay, all right, so let's just revise what we did before. So we're going to start by calculating VB. So we need to know what is RB slash O. In this case, it is given the length of OB is 0.15 meter. So we have RB slash O is equal to minus 0.1299 I plus 0.075 J. and we know VB must be 90 degrees to this. Okay, so you can calculate VB using this equation. This is for rotation. Okay, so therefore it is equal to minus 8k, minus 8 because in clockwise. Okay, counterclockwise is always positive. Then you have this IJK cross product. All right, and in the end we have VB is 1.039J plus 0.6I meter per second. So then we can proceed with the general plane motion part. So we need to know RA slash B. It is given the length 0.5 meters. So you do cos 60 degrees for I, sine 60 degrees for J. This is a spelling mistake. This should be J. So you have 0.25 I and 0.433J. That is for RA slash B. And we know that VA is pointing to the right because this thing is moving in clockwise direction. So definitely point A is moving to the right. All right. So VA then equals to VB plus omega AB cross product RB slash A. And also we know that VA is equal to VAI positive because it is moving to the right. Okay, moving to the right. All right, so then we will substitute the values. This VB goes here, omega ABK, this is unknown, so we assume that it is positive. Cross product RA slash B. Okay, then we have this, and in the end we separate into IJ component, and finally we have VA equals to 2.4 meter per second. Omega AB is minus 4.157, which means that omega AB is actually rotating omega AB is actually rotating clockwise. So this is omega AB, right? Okay, so now we have these two quantities. Now what we want to do is we would like to calculate the acceleration. So we have VA and omega AB. Therefore, we will start by calculating the acceleration of point B. Okay, this is point B over here. So we want to calculate what is the acceleration. So AB, this is a rotation. Okay, point AB, OB. OB is having a rotation, the disk. This is rotating in clockwise direction. So AB will use this equation, alpha OB, which is given, this one. This is 16 K, and it's going to be minus because it is clockwise. Cross product RB slash O, we have this omega OB is in scalar quantity, so you will just put in 8. There is no need to put IJK component, and obviously there is no need to put the negative sign because negative sign indicates direction, and since this is scalar quantity, so there is no direction indicated. Okay, so this is what we have. AB is equal to minus 16K, which is alpha OB given. Okay, here it's given 16K. Cross product RB slash O we have from previous. And here you will notice that it is 8 square. So without any negative because this is a scalar quantity. This is a scalar quantity. Sorry. Okay, this is scalar. All right. So then we have AB is 2.0784J from the multiplication. We will get this. And obviously, so you will just add these two, the J component, and also these two for the I component. So finally we will get AB is equal to 9.51 I minus 2.72 J meter per second. So we have already the acceleration of point B. So now what we want is the acceleration of point A. Okay, so now we go to AA equal to AB, which we have calculated just now. So this is the equation for general plane motion, GPM, right? So AA, we take the value of AB, substitute. This one is the value of AB. Alpha AB is unknown, it's not given, so we will assume that it is positive. So just put in alpha ABK. Cross product RA slash B is the position vector we have previously. And this is again a scalar quantity. So we will take the value from here, which we have determined before. And you notice that this is a negative sign here, negative sign. And because this is a scalar quantity, so you don't have to write the negative sign. So just put in the value 4.157 square and again multiply with the position vector RA slash B. All right, so we know again that AA, the acceleration of point A, can only move in x-axis. So we definitely know that AA is AAI, positive, because it is moving to the right. All right, so then we substitute AAI equals to all of this. All right, you do all the multiplication, vector cross product, and so on. And finally, as usual, we will separate the components into I and J component and solve simultaneous equation using your calculator. And in the end, you will get AA is equal to minus 12.48, which means that this direction is actually incorrect. So in fact, AA is actually pointing to the left. All right, AA is pointing to the left. And we have alpha AB equals to 40.82 rad per second square. So which means that alpha AB is rotating in counterclockwise direction, whereas the omega AB that we have determined just now is rotating in clockwise direction. So this is totally normal. This can happen. The angular velocity is in clockwise direction, whereas the angular acceleration is in counterclockwise direction. So this will be the final answer for this type of question. So what you will have is in the end this. This is the first answer. This is the second answer. And you have this AA as well as alpha AB. So that completes this